I investigate the theory. What I have to do is investigate the concept of rates of change and how it is related to motion equations, derivatives, equation of position, velocity and acceleration.
The problem is that a rock is thrown upward and its position function at any time is given by h s t is equal to minus 16 t to the 2 plus 64 t plus 96. We need to calculate is the derivative of the position function using the limit definition. Okay, the derivative is this and the limit division is this. So we need to substitute this value on each f of x. So we need to put limit h approaches 0. So we need to put this and then everything over h. This is like the substitution. Then we need to put limit h approaches 0. This we need to like factorize, and then we need to like change all the signs. Then we need to put again the limit h approaches 0, and we're gonna like do this over h. Then we need to put limit h approaches 0, and we're going to eliminate like this and this. This no, this no, this yes, and then this and this. So we have minus 32 th less 16 h to 2 plus 64h over h. And we need to like eliminate the h, because if we like leaving there, we're going to have like 0, so that's what we don't want. So we're going to factorize this. Then we put again the limit h approaches 0, and we have like the without the h's. Then we are going to substitute this h with 0, so it's going to be 0, and the function is going to be like v t is equal to minus 32 t plus 64. This is the velocity function. We need to graph the position, so we use this formula and we put values on t like in x, and these are going to be 3 points in the graph, and this shows that the graph of the position is like a parabola.
Well, we are going to calculate the velocity of the rock by making substitution these points to this. Now we're going to make the line to unit the points, and now this shows the velocity of the rock. Now I'm going to explain the acceleration function. When the problem shows you that the fall is a free fall, it's always going to be a constant acceleration. It will not change. It says minus 32. Now we put it in the graphic. And that shows that the acceleration is always constant. The question is, what is the connection between acceleration, velocity, and position? Velocity is the derivative of acceleration. Acceleration is the derivative of velocity in the time approaches to zero.
Now the question says, calculate the time when the velocity is a half of the initial velocity. We know that this is the initial velocity and we need the half, then is 64. Then we put the 32 over here, that is the velocity. And now we have to do the equation that this one you pass it resting 32. Then 64 minus 32 is minus 32. Then the minus 32 passes dividing. And the answer is that t is equal to 1.
It can be concluded that the use of the formula for derivatives is useful to solve physics problems. Also, the parabolas that are occasioned because of the gravity, the direction, and the angle from where an object is thrown. An example, it could be a baseball game when the player throws the ball that generates a parabola.